Using the substitution u equals cos x plus 1, or otherwise, show that the integral from 0 to 2 pi of e to the cos x plus 1 sin x dx is e multiplied by e minus 1. So as we always do when we do integration by substitution, the first thing we're actually going to do is do some differentiation to get our dx. So I'm going to differentiate both sides here with respect to x. Cos x differentiates to be minus sin x. The 1 will differentiate to be 0. I'm now going to make dx the subject, so I'm going to move the dx to the top here, and I'm going to move the minus sin x to the bottom. So I'll get du over minus sin x equals dx. And in a minute, I'm going to substitute this in instead of the dx here. The next thing I want to deal with is the limits. So I can see that currently I've got x limits of pi over 2 and x equals 0. Let's work out what those would be in the u world. So when x equals 0, u is cos 0 plus 1, which is 1 plus 1, so 2. So my lower limit is 2. When x is pi over 2, for the upper limit, u is cos pi over 2 plus 1, which is just 1, because cos pi over 2 is 0. So my lower limit is 2, and my upper limit is 1. Right. Let's go back to our integral then. Like I said, the lower limit is 2, the upper limit is 1. Now we've got an e to the power. Now the power, the cos x plus 1, in the u world is just u. We know that u is equal to cos x plus 1. So I'm just going to get e to the power u. We've then got the sin x. I'm just going to write that down here because in a minute you're going to see that we're going to get some cancellation when I substitute the dx in. And like I say, we can now see that the sin x's are going to be cancelling out, so I didn't need to worry about converting sin x into the u world. I do still have this minus 1 on the bottom there though, so that would change the overall sign here. So I'd get minus e to the u du. But one little trick I can do, I can change this to be a positive as long as I change the limits around. So I can swap this to be the integral from 1 to 2 of positive e to the u. Integrating the exponential then, e to the power u integrates to be e to the power u. Substitute my upper limit in, I get e squared. Substitute my lower limit in and take them away. So I've got e squared minus e to the power 1, which if I factorise an e outside, I get e minus 1. E times e minus 1. The e times the e is the e squared. And the e times the minus 1 is the minus e. So we have shown that that integral gives us the desired answer.